Welcome students. In this lecture, let us look at the concept of confusion matrix for learning algorithms. So whenever you want to analyze the performance measures of a machine learning algorithm, especially for classification applications, the first thing you need to have is a confusion matrix. So what is this confusion matrix all about? It is a matrix depending upon the number of output classes you have. You can have a 2 cross 2 matrix, or you can have a 3 cross 3 matrix depending on the number of classes of your application. So if you have a matrix, you must have a row and a column. So when you look at the row, it is actually the actual number of classes and the data within that classes. And when you have the column wise appearance, it is what your machine learning algorithm is going to give, the results what you are going to obtain from the experiments. So when they both match with each other, then we say your performance is on the top. When they do not match, their performance is not good. So how do we find? So as I have already told you, the performance measures are calculated only on the testing data. Now, if you have 165 samples as per this specific example, 165 samples, maybe among these 165 samples, 65 samples are on one category, 100 samples are on another category, right? So when you test with a specific sample of say no class, you need to check what is the output given in your from your experiment. So if that is also no, then row wise no and column wise no. That specific point will get added with a number 1. Similarly, you take another testing data, and again if it belongs to the category no, and again your machine is successfully able to give the answer as no, then this specific point will become 2. So each time when there is a match, the number will keep on increasing. Suppose if there is an image or a data from the no category, and if your machine says it is under yes, then you can find out that specific location will be added or count with 1. So this process will continue for all the testing samples which you are going to have in your experiment. Once you have the matrix, say for example, we can take a 2 cross 2 matrix. So you will have 4 locations on 4 different points. Now from these 4 different points, you have different names, or the pixel location, you have different names. One is called as true positive, the other one is called as true negative, false positive and false negative. So which one is true positive? So you have to clearly understand what is meant by true positive. The second term, true positive, in this the second term which is positive indicates the real time situation or the actual situation. Say for example, if a patient is COVID positive, then the second term will be positive. Now, when this COVID-19 positive patient is tested, and when your machine learning algorithm also says that this patient is COVID-19 positive, then we call it as true. The first term corresponds to what your algorithm is going to give. So when you say true positive, the real-time situation or the actual prediction is positive, and your machine is also able to give correctly as positive. Next comes your true negatives. So what is this true negative all about? When you say negative, that patient is free from the disease. He is not a COVID-19 patient. So when this patient is taken into account, we call it as negative. When this patient's data is given to the machine learning algorithm, and your machine algorithm, if it says that this patient is not affected by COVID-19, again the prediction is correct, then we give the name as true. So if the machine is able to give a correct prediction whether it is a positive or negative, the first term always takes the word true. So true positives and true negatives are very good for your classifier, and it should be always very high. Whether they are class number 1 or class number 2, your machine is able to predict them correctly. Next comes your false positives and false negatives. Now again, the third one, positive means the patient is COVID-19. But what happens here is the machine predicts wrongly that the patient is not affected by COVID-19. That's why the first term takes the word false. Your output from the machine is not correct. When you look at the fourth one, false negatives, when you say negative, the patient is not, or the human being is not affected by COVID-19, but your system or your machine says he is affected by COVID-19. Again, the prediction is wrong. So both false positive and false negatives are undesirable values. Those values should be as less as possible. Again, among these two, which one is dangerous? It is clearly evident that false positive is more dangerous than false negative, because it is a life or death situation where your application or your system is giving a false decision which may be fatal for that specific patient. So all the classification algorithms always make sure that they try to reduce false positives and false negatives. Predominantly, reduction of false positive is very important. Now from these confusion matrix, we can calculate several performance measures. Here I want to iterate that different types of applications, they have different types of performance measures. Because I have taken classification as one of the problem specification for the presentation, all the performance measures given here will be related to the classification problem. Here you have accuracy. So when you say accuracy, it is the number of correct predictions, or you can say true positive plus true negative by total sample. Again, you have specific situations where one performance measure will not be specifically useful for the application. Most of the time, the research students or those who are doing project, they just like that take it for granted. They take the performance measures, but they need to analyze whether this performance measure is really useful for them, because each performance measure's characteristic features are different. It works well only if there are equal number of samples belonging to each class. Right? Consider that there are 98% of samples of class A and 2% in class B. So when you train 60 is to 40 or 70 is to 30, you are going to supply very less number of training samples from class B, which indicates the machine will definitely not able to recognize class B data. In that case, your classification accuracy may look high, because 98% of your class A would have been correctly classified, but still, practically speaking, when there is a data from class B, your system is going to fail, irrespective of showing high accuracy. This is one example which I have given. Then you have the other performance measures like sensitivity, specificity, then precision, recall, false positive rate, and positive analysis and negative analysis. You can do either in the positive way or you can do in the negative way. Several mathematical equations are available to judge the performance of classification algorithms. I have given two equations here, but I will advise you that you have to understand. If you say false positive rate, they are giving importance to false positive. So what should be the value, whether it is should be a higher value or a lower value? Such type of analysis is very important when you go into the classification.